Before we start constructing logic circuits, let's look at how a breadboard works. So a breadboard allows us to construct a circuit without actually doing any soldering. So we connect each component to the different nodes or points on the breadboard. Now for the top two and bottom two rows, each node in that row is connected. But the two rows are not connected to each other, as we can see. And for column 1, with node A to E, the nodes in that column are connected. And similarly for column 2, but the columns are not connected to each other. And we have another block of columns with nodes F to J, where the nodes are connected to each other in each separate column, but the two columns are not connected to each other. So let's build a simple circuit to demonstrate the use of the breadboard. So we'll have a power supply, and we'll connect the positive terminal to the bottom row. And we'll change the color of the wire to red. And for the negative terminal, we can connect it in either row, but let's just connect it to the top row to demonstrate the closed loop of the simple circuit we're going to build. So we'll change the color of this wire to black. And now we'll put a diode which will light up if our circuit is correct. So our LED or light emitting diode we'll place in its separate columns. Now note that the cathode of the power supply is positive and the anode is negative. So the electrons flow from the anode around to the cathode. So we can look at the anode as repelling electrons, while the cathode accepts electrons. So similarly, the cathode in a diode is going to accept electrons, so we're going to connect it to the ground. So this row is all connected, so let's just move the diode down a bit, so we can connect the wire from the cathode of the LED to ground. So that means now that this row is connected to this column, which is connected to the cathode. And at the other end of the diode, we're going to connect that to the positive terminal. So we'll change the wire color to red. And now if we run this simulation, we can see that there's too much current going through the diode. So to fix that, we'll add a resistor. So let's stop the simulation and add a resistor, which is going to dissipate some of that current. So what I'll do is get rid of this wire and connect the resistor directly from the ground to this column. So basically we're connecting it to the cathode of that diode. So let's keep the resistance the same and run a simulation. So now the diode lights up as normal. And as we can see, we have a closed loop circuit. So we have a connection from the ground to the resistor, to the cathode of the diode, to the anode, and then down to the cathode of the battery. And you can visualize this using the schematic view. So as you can see, the diode and the resistor are connected in series with the battery. And I'll provide a link below to Tinkercad, which will be useful to you. So you can make a free account and have a play around with different circuits.